Yes, okay, cool. Well, good afternoon. My name is Yassin Sabahi. I study artificial intelligence at the Vrije Universiteit of Amsterdam. Today, we're going to discuss my research. The title of the research is Optimizing Neonatal Respiratory Support through Network Modeling. In other words, we are going to investigate if an AI coach can help with the process of respiratory support of babies. Some facts about babies. There are 166,000 babies born in 2022 in the Netherlands. Approximately, that is 457 per day. That's 19 an hour. And 7% of the deliveries that are happening do need respiratory support. And the babies have respiratory distress. The importance of respiratory support on babies is preventing conditions like PBD, that's bronchopulmonary dysplasia. This is a form of a lung disease that affects newborns, and with such conditions, it's important to receive the right help and the right respiratory support, so the consequences will be minimal or none. And artificial can be a solution to avoiding errors or avoiding that the doctor forgets to do something during the process. And we are going to discover if an AI coach can help with this. Why do we use network modeling? This approach involves the construction of network models representing various states, relationships, and enabling the simulation and analysis of different scenarios related to respiratory support. What we're going to do is we have an approach of 3 scenarios. The first one is a scenario where everything goes well. So the doctor follows the process, does every procedure right, and knows when to intervene and when not. The second scenario is when the doctor skips a step. As you can see, he's going to skip the step between gasping and SAPAP. So after concluding that the baby has the condition gasping, he will not perform the SAPAP, so he will not open the airways, consider SAPAP, SpO2, and ECG monitoring. And in the third scenario, we are going to build an AI coach that monitors the process and identifies when the error occurs. And when it does, and only if the error occurs, he has to intervene and give knowledge to the doctors to prevent this error from happening. This is the network model we built. As you can see, it's very complicated, and if you see it. And you have the base level, that's the one underneath. The middle one is the first level, and the one on the upper side is the second level. In the base level, we have the world, the AI coach, and the monitor state. This is the world. This is a hectic place to be, as you can see. This represents the process, the procedure of when to do what. For example, when after the baby is born, we start to evaluate the heartbeat, and then we see if the baby has gasping or inadequate heart rate. And after that, we see which procedure we need to follow, etc., etc. And at the end, we have a briefing of when the baby is healthy and how we did. Then we have the doctor. The doctor is a mental state. This is the mental state of the doctor. Here are all the procedures that the doctor needs to follow and the knowledge of it, because in one level above, so in the first level, we have all the wait states. These wait states are connected to the doctor's mental state and also connected to the monitor states. And this is the AI coach. The AI coach, the goal for this is knowledge enhancement. So the goal is that the AI coach can enhance the knowledge of the doctor if needed. So when it's not needed, the AI coach should do nothing or should just follow the process. And the knowledge enhancement comes with the help of the monitor state. So the monitor state looks at the knowledge of the doctor. And if there's no knowledge about a procedure, then the AI needs to fill that in. by sharing its knowledge from the weight state of the AI coach to the weight state of the doctor. And also this connection has a weight state. So this is how it looks like, how they share the knowledge. Combination functions that are used in this network model are allogistic and ID. This is the interaction between the states, and allogistic is the gradual changes that comes with passing the value, and ID is just passing the value as it is. Well, these are the findings of my research. This is the perfect situation. On the left side, you see every procedure that is being made in the scenario. And on the right side, it's a specified graph. This graph only focuses on the CPAP, SPO, ECG state. So the one in the world, the one of the doctor. And the scenario 2 and 3, you will also see the one of the AI coach and the monitor state. And on the upper side, on the value 1, you see the weight state because there is knowledge. You see that the doctor performs CPO, as CPAP, and that is also happening in the world. This is scenario 2 and scenario 3. Oh, sorry. This is scenario 2 and scenario 3. As you can see at scenario 2, we turned off the relation between gasping and CPAP. So the doctor doesn't have any knowledge about performing CPAP after seeing that the baby has gasping. So so every value is at 0. He doesn't know how to perform it, so the knowledge is 0. He doesn't do it, so the world state and the mental states are also 0. And at the right side, you see scenario 3, where we implemented an AI coach with the monitor state. And as you can see, the monitor state increases till 0.5. So it sees that there is indeed something happening. So there is an error. And you see that the knowledge, so the weight state, the knowledge of the doctor of performing the CPAP starts at 0 and increases till 0.9. The opposite happens with the doctor, with the AI coach, because the AI coach passes its knowledge. So that one goes from 1 till 0. And so we did what we want to do with the AI coach. But what we also find is a ripple effect, what I didn't expect, but it seems quite logical. Because on the left side, you see scenario 1, and on the right side, you see scenario 2. So on the left side, everything goes well, and you see that everything is performed on with a high value. And on the right side, every procedure that the doctor needs to do is happened very early in time, and also happened at a lower rate. And it's quite logical, because when you have a baby that's gasping and you don't fix that problem, you will indeed not get the right outcome if you follow the rest of the procedure while skipping the step to heal the gasping. Limitations. While the AI coach serves as an educational tool, the effectiveness of this feature is yet to be validated for in real life, because there's a need for future research to understand how effectively this knowledge transfer is from the AI coach to the doctor, because now we assume that this transfer goes perfectly, but we don't know how the doctor will pick the knowledge up in real life. AI also becomes more integrated into the healthcare, so ethical considerations surrounding data privacy will become more important. And also inaccurate data in the AI would cause wrong recommendation. So it should be very important that the data is structured good and also processed in the right way. These are the references I used for this presentation. And this was my presentation. Questions? Ask an AI.